question number 1 should look familiar to you in that it was on your test where we had you draw vectors geometrically and they have a certain magnitude and a certain direction. Jake, when we drew these, did we use a protractor or did we estimate?
I used the ruler.
The angles, when we drew the angles, did we?
I estimate.
We estimate. And then for the magnitude, how did you use the ruler?
I scaled it, so like I just made every 110.
Every 110, okay. Centimeters or inches or?
Centimeters.
You probably could use it as 1 centimeter as being 5. I think you have enough space to do that, but I guess it's okay if you made 1 centimeter 10. It's just your picture's not very big, so there's really you could do it as 5. So you would begin by making your XY axis. And when you draw your first vector at 105 degrees, Jake, roughly where does it go?
Closer to the 90.
In quadrant 2, but closer to 90. And is it okay if I use 5?
Yeah.
So 40 miles per hour means it's going to be 8 centimeters long. So I would estimate the 105 and draw a vector 8 centimeters long. And of course, we always label things wind 1. Jake, then what would 299 look like?
It's a 30 of the 270, so quadrant 4, closer
It's
to
in
the
quadrant
270.
4 and about 30 degrees into quadrant 4?
Yeah.
So
closer to the
further
270.
in than this one was from this,
Yeah.
right?
Yeah.
And if it was 30, then it would be 6 centimeters. And so maybe, does that seem like a pretty good estimate?
Yep.
Okay. And label it. And now we have one with a direction of 170, so where does that go?
Very close to the 180 in quadrant 2.
Very close to the 180 in quadrant 2. And 55 miles per hour, so this is
Should be
supposed to be the
longest
biggest one. And it's also the one that's the closest to one of the quadrants, so does that seem
Yeah.
pretty reasonable?
Yep.
So all of these were just drawn as what kind of vectors? Position vectors, because they started at the origin. Jake, you have a vector has a head and a tail. Which one's which?
The head is the side without the arrow.
Well, do you remember what we call the arrow? What do we call the arrow? A hat. Where do you put your hat?
On your head.
On your head. So this end is the head of the vector, this end is the tail.
That makes sense.
So now, we need to translate them. So we need to take vector 2 and translate it so that it's
We need the tail of vector 2 on the head of
at the
vector
head
1.
of vector 1. And we, oh whoops. This one. So we take this one, which we drew before as 6 centimeters long, and we drag it up with our ruler, and we make another one 6 centimeters long. And then we do the same thing for this one, except that the
Tail of vector
tail of
3.
3 goes at
The head of the translated
head
2.
of translated number 2, but we use the ruler and we drag it up. Henry, is this on your paper? Is it accurate on your paper? And then finally, we always need to remember to draw our
Resultant. vector.
resultant vector, which you could label as R, or based on the instructions, you could label as
W1 plus W2 plus W3. Oh, F.
or F. The way we draw it is it starts where everybody starts, and it ends where everybody ends. And if we connect this, we now have our vector R, or our vector W1 plus W2 plus W3, or our vector F. Please remember that the correct notation for a vector is to put a ray on top of the vector. Now, we're not done, because Jake, we still have to,
I stopped there.
okay, but according to the instructions, we're not done because we still have to,
Find the magnitude and direction of the final vector.
we still need to find the magnitude and direction of the final force. To find the magnitude and the direction of the final force, we're basically saying that we need that angle as the direction. So we know when we get the answer that it should be
In between 180 and 270, and probably closer to, 90 and 180, probably
should be
closer,
between 90 and 180,
closer to 180.
approximately.
135 maybe.
Okay.
140.
And then judging by the length of it, the magnitude of it, it should be around,
40, maybe.
I would say that it should be almost as long as this one.
50.
So somewhere between 40 and 55, something like that,
Yep.
right? You do not find the resultant one by taking the magnitudes and
Adding them.
You do not find the direction by taking the angles and adding them. You must switch them into,
Other form.
what's that other form called?
Polar.
No,
Rectangular.
wrong, standard. Components.
Components.
So a vector can be expressed in terms of magnitude and direction, or a vector can be expressed in terms of components. When a vector is expressed in terms of components, it is xi plus yj. If it's a two-dimensional vector, plus zk if it happens to be a three-dimensional vector. So if we want to find the magnitude and direction of the resultant vector, then we have to change each one of these vectors into their components. The fastest way to accomplish that is to do all the x's at once. So that would be 40 cosine, Jake.
Sorry, I didn't write down the direction on my paper.
40 cosine,
105.
105 degrees, plus
30 cosine 299.
30 cosine 299, plus
55 cosine 170.
55 cosine 170. In the interest of time today, so that we can get as much accomplished as possible, you can go ahead and do the whole thing on the calculator and give me your answer, as long as we all agree with it. But if this question was on your final exam, I would show more work, so that if you make a careless mistake somewhere, we can see how large of a mistake it is. And Jake, what do you eventually get?
negative 21.869.
Negative 21.869?
Yeah.
So negative 21.87?
Is that wrong?
Is that wrong? What do you guys have?
Oh, I put +5 because.
So thus, in, reiterating why you show more work, because you do make careless mistakes.
Mhm.
When a calculator's in front of you, our mind tends to stop working as hard.
It's 16.355.
Excuse me?
16.355.
You can tell by looking at this
Yeah, no.
that your X value definitely has to be negative. Maybe his first answer was correct, you guys. Sari?
I did it twice and I got negative 49.97.
I got
Okay.
that too.
Jake, your calculator's in the wrong.
That's probably what it is.
Your calculator needs to be in degree mode.
Yeah, it was.
Now, Jake, we are taping today,
Sorry.
so you might want to step it up a little bit. Now, if you look at this, you expect the Y component to not be negative, to be positive. You also expect it to be a much smaller number in terms of its absolute value. So this is what you would do to find it: 40 sine 105 plus 30 sine 299 plus 55 sine 170, the magnitude times cosine of the direction, the magnitude times sine of the direction, and this time, what do we get?
Alright, I can do this. 21.949.
Do we agree?
Yes.
Maybe that's the one you got first.
Mine was in radian.
Okay, 21.949.
949.
Okay, so 0.95. So we just found out that our resultant vector is negative 49.97I plus 21.95J. To find its magnitude and direction, you can look at this picture again. You're finding the hypotenuse of a right triangle
Oh, yeah.
whose horizontal side is negative 49.97 and whose vertical side is 21.95. And then to find the direction, you use which trig function? Tangent. And you make sure when you get your answer that you end up in the right quadrant. So to find the magnitude, we will do the square root of negative 49.97 squared plus 21.95 squared. Again, in the interest of time, go ahead and just give me your answer. Since these other magnitudes were 40, 30, and 55, this would not be the appropriate time to leave a radical. If it says on the problem, leave your answer as simplified radicals, then it is appropriate to do that. But in this case, it makes more sense to get a number so you can compare it to some of these other numbers here. And what do we get?
54.578. So
54.578, so 0.58.
8.
Is that wrong? Okay. And should there be a label for it? What were the other magnitudes? Miles per hour, so this one should be miles per hour. Then when we do the direction, we take tangent of theta as sine over cosine, So 21.95 over negative 49.97. Jake, tell me what your calculator gives you before you do anything with it.
Negative 1.748. It doesn't seem
Negative?
Right. It doesn't seem right.
I can't hear you.
I got negative 1.748.
Negative 1.748? Did you guys get that? Could you please make sure your calculator's in degrees?
It is. I take the inverse tangent of that,
Inverse
right?
tan, did you close your parentheses?
Yeah.
What do the rest of you get? Come on, you guys.
Negative 23.7.
Negative 23.72?
7-1.
Yeah.
Okay.
Why am I not getting that?
Jake, come on.
I don't know why I'm not getting that. I put it in correctly. I checked.
Then use one of my calculators. We don't want another hour of this.
Sorry.
However, that angle is not in the right quadrant whatsoever. What do we have to do to it? Add 180. When you add 180, what do you get? 156.3.
Just divide this first, and then I take tangent of whatever.
So we found out that our resultant wind is blowing at 54.58 miles per hour in a direction of 156.3 degrees. That was a good problem as practice because it brought in drawing the vectors. It reminded you that vectors are drawn in standard form as position vectors with their tails at the origin. And when you draw resultant vectors, after you draw them as position vectors, you translate them. It also got us to remember the conversion when you want to change your magnitude and direction into components, and it works exactly the same way for 2 and 3D, really, but mostly this is 2D, not 3, because finding the angle would be a little weird in a three-dimensional space. We reviewed how you change from magnitude and direction to components, and that is necessary anytime you want a resultant. And that to find the magnitude and direction of a resultant vector, it requires changing them to components. You don't just add the magnitudes and add the directions. So this was a good problem, and it also went over making sure you're in the right quadrant. If you think about it, being in the right quadrant was a discussion we had back in August. And here we are at the end of math analysis having the same conversation. It's time to make sure you're in the right quadrant. What is it about the calculator that puts this in this quadrant over here? The calculator only uses the principal branch. So it will only give you angles in these two quadrants for tangent and sine, and these two quadrants for cosine. Any questions? Okay. And now we have our second question about vectors. We are to assume on this problem that these 3 points, A, B, and C, happen to be the vertices of a triangular roof. And the most important word in the problem is area. And you know that, for one thing, because I underlined it. And so now you have to go back in your memory and try and recall, when did area come in with vectors? Did you remember, Jake?
I found in my notes. I think I did it correctly.
So area comes in as what? An application of?
Cross product.
Cross product. Once you find cross product, there are two areas that the magnitude of the cross product can affect or create. One of them is the area of a
Triangle.
triangle. The other one is the area of a
Cube or square.
parallelogram. Just as always, what have you always had to do when you found the area of a triangle? Multiply it by
Half.
1/2. So it's the same thing here. The magnitude of the cross product is the area of a parallelogram where the two vectors you find are adjacent sides of the parallelogram. And for a triangle, it's half the magnitude of the cross product. The very first thing you have to do on this question is create what kind of vectors?
Displacement.
Displacement vectors. So you find the vector that goes from point A
Point B.
to point B, and you find the displacement vector going from
A to C.
point A to point C. What's the most important thing to realize? Kylie, I can't give you more than about 15 or 20 more minutes. Everybody else was pressed for time too, so I have to be fair about it. Right?
Yes.
I heard you guys were pressed for time. The good thing about having as many questions on the quiz as it did is that you can miss more and still get a good grade, right? But I can't give unlimited amounts of time for people making it up. I can give you a few more extra minutes because the room's a little bit noisier than it would be, but I cannot give you all the period. So the most important thing to remember about displacement vector AB is what, Jake? Which subtracts.
Oh, the 3 minus the negative 2.
Right, you do B minus A. So you do 3
Minus negative 2.
So 3
Plus
plus
2.
2I
Plus
and
negative 4 minus 5.
negative 4 minus 5J
Plus
and
9 minus 7K.
9 minus 7K. And you get 5I minus 9J plus 2K. And then you do the same thing for AC and you get 11
Plus 2I.
plus 2I plus
0 minus 5J.
0 minus 5J plus
Negative 5 minus 7K.
negative 5 minus 7K. Ultimately, you get
13I minus 5J minus 12K.
and then you do cross product. The first row being IJK, then Jake,
5, negative 9, 2.
and finally,
13, negative 5, negative 12.
and this next process, do you remember what it's called?
Expansion by minors.
Very good, expansion by minors. So you do vector I, you cross out the row and column containing I, and you're left with the 2 by 2 determinant of,
Negative 9, 2, negative 5, negative 12.
good. And then what sign comes next?
Minus, right?
Minus, yeah. And then you cross out the row and the column containing the J, and you have,
5, 2, 13, negative 12.
and then what sign?
And then plus.
Plus K. You cross out the row and the column containing the K, and you're left with,
5, negative 9, 13, negative 5.
and then for all of these I, J, and K, you are finding the, starts with the letter D,
Determinant.
determinant And what formula finds that determinant?
AD minus BC.
AD minus BC. So, vector AB cross vector AC is going to be what?
Final answer.
Well, no, 108
Oh, 108 plus 10 I
plus 10 I
minus
minus
negative 60 minus 26
negative 60 minus 26
J.
J plus
negative 25 plus 117 K.
negative 25 plus 117 K. And then you get
The final is 118 I minus 86 J minus.
actually plus 86 J,
Oh yeah.
because it's a minus 86 and then
Yeah.
it's minus a negative, so plus 86 J.
Minus 8K.
What was the last bit?
Minus 8K.
Isn't this negative
Oh, I
25
did.
plus 117?
Yeah, I did plus.
Come on, Jake.
I did plus 17. 92
Plus or minus?
minus plus
Try again.
plus.
And now, since it's area, we need to find the,
Cross product.
we just found the cross product.
The
We need to find the,
square root of all those
and
together.
that's called finding the magnitude of the cross product, which is the square root of 118 squared plus 86 squared plus 92 squared. Just to make sure we're all on the same page, why don't you tell me what you get before you take the square root of it?
$29,784.
Do we agree? And that is approximately,
172.58 feet, or whatever it was.
we don't have a label here, but what do we also have to do?
Squared units, unit squared.
What we
Multiply
also
by
have
half.
to do, divide by 2, multiply by 1/2, divide by 2. You do that anytime it's a triangle. And now you get,
86.29 units squared.
and then since we don't know the unit, we just say units squared. So in these two problems, I feel that we reviewed an awful lot of concepts from vectors. You have a test on vectors, you have a quiz on vectors, you have a homework packet on vectors. I will be putting up some reviews for you on Schoology. They are optional to do, it's up to you. I'm not sure, but definitely before I leave tomorrow, at the end of the day, they'll be up. If I can get them up today, I will. If not, I'll get them up tomorrow. And there will be a review for each unit. Okay? Any questions so far? How many of you are glad that we reviewed vectors? You have a question?
Yeah, what's the rule for picking the two sides that you didn't know? Make.
We tend to take the first point and use it the most. So A, B, and AC. But it should work with the exact same answer if you did A, B, and BC. With a triangle, you just have to make sure sides are adjacent, and with a triangle, all sides are adjacent. With a parallelogram, you have to make sure the sides are adjacent. Any questions? Okay. We're moving to polar coordinates. All of these complex numbers right now are in rectangular form, a plus bi. And in order to do a lot of the things that you've been asked to do here, multiply them, divide them, find reciprocals, raise them to powers, and take their roots, you really have to, especially for D and E, change them from being in rectangular form to being in polar form. So you're changing an A plus BI into an R cis theta. You could multiply them without doing that, or divide them, but you certainly wouldn't want to take Z2 and raise it to the 5th power when it's in rectangular form. You've been prompted to first change them to polar form, and because these questions were not pre-written to come out nicely, you were given permission to round your angles to the nearest whole number and to round the sides to the nearest tenth. However, in order to make sure they are in the right quadrant, it behooves you to graph them. Even though the R, which is known as your, starts with M, modulus, is like a vector's magnitude, but it's a polar number's modulus. So it's the same thing as we did with vectors. Theta, which was the direction on a vector, is the what on the polar number? You have moduli and arguments. Good. You'll get your modulus right no matter what, but your argument might not be in the right quadrant. So it's always in your best interest, John, to graph them so that you get them in the right quadrant. So 3 minus 6i means we went right 3 and we went down 6, and then it's time to find the hypotenuse of this triangle. Okay, Tomomi. And so you take the square root of 3 squared plus negative 6 squared. And before you do anything with it, Jake, you have the square root of
45.
But since I told you to round them to the nearest tenth, I did not say leave it as a radical. Then I am inviting you to take the square root of it and get
6.71.
So round it to the nearest tenth.
6.7.
6.7. To find the angle, you once again use tangent. And some of you do these backwards. And when you do them backwards, it's because you didn't draw it. But tangent back first semester was what over what? Sine over cosine as well, right? Which meant it was the y over the x, right? So you're doing tangent of theta is negative 6 over 3. Do make sure, honestly, I can't think of a single reason right this minute why you would be in radians. I think you'd be in degrees. Right? So keep your angles, keep your calculator in degrees. Before you change it, what does your calculator give you?
Theta is negative 63.43.
Negative 63.43. Okay. Rounded, so negative 63.4, but we're going to round that to the nearest whole in a minute. However, we know with polar coordinates that our argument theta is always supposed to remain between
0 and 360.
0 and 360. So think about it. What do you really add?
360.
360. Not 180, because you usually add 180. 360 because your triangle's in quadrant 4. And now what do you get?
296.6 degrees.
296.6 degrees. So we just changed Z1 from being 3 minus 6i to being 6.7 cis, and 296.6 rounded to the nearest whole is cis 297. Now we're going to do the same thing, except we're going to go left 2 and up 4. And it's going to be the square root of -2 squared plus 4 squared, which, Jake, is the square root of 20, which you've been invited to round to the nearest tenth, so it's
4.5.
4.5. To find the angle, you once again are using tangent, and you actually are doing tangent of the same ratio, because you're doing tangent of theta is 4 over -2.
Yeah.
So you pretty much know your calculator's going to give you -63.4, right? But now, based on where the triangle's drawn, what do you add?
180.
180. And when you do that, Jake, you get
116.6.
and you were invited to round it to the nearest whole number. So Z2 in rectangular form is -2 plus 4i, and in polar form is
4.5 cis 117.
4.5 cis 117. And now we're going to do it one more time. This one's actually the easiest one, because anytime your triangle is in quadrant 1, the calculator has no ability to be wrong or misleading. First, you get the square root of 65, which, Jake, you approximate to be
8.1.
8.1. And then once again you use tangent, and you're doing inverse tan of 1/8, and your calculator tells you it's
7, but that's not right.
7.1.
7.125. Yeah.
So
Is that right?
7. And so now you have that Z3 in rectangular form, 8 plus I. In polar form, 8.1 cis,
7 degrees.
7 degrees. And now that you have these, you can do a multitude of operations. The first one being multiplication of 2 complex numbers in polar form. You were taught, Jake, that you take the moduli and multiply 6.7 times 4.5, and you take the arguments and add 297 plus 117. For the moduli, Jake, you get
11.2.
6.7 times 4.5. You
Right.
multiply the moduli, you add the arguments, You do not add the moduli. In fact, there's never an instance where you ever add moduli.
30.15.
30.15, so if we rounded that to the nearest tenth, 30.2. When you add 297 and 117, Jake,
414.
414. However,
You have to subtract.
angles always have to be between 0 and 360, so you
Subtract 360.
subtract 360, and your final answer for Z1 times Z2 is 30.2 cis,
54 degrees.
54 degrees. Anthony. Question B is asking you to do Z3 divided by Z1. Jake, what do we do to the moduli?
Divide.
Divide them, so 8.1 divided by 6.7 cis, and what do we do to the moduli?
Subtract.
Sorry, arguments, subtract. So 7 minus 297. Jake on the calculator, 8.1 divided by 6.7,
1.21. So 1.
so 1.2. If you do 7 minus 97,
297.
7 minus 297, you get
Negative 290.
negative 290, which once again is not between 0 and 360. So you
Add 360.
add 360, and your final answer is 1.2 cis,
70 degrees.
70 degrees. Questions or comments so far? How many of you are feeling like this is actually coming back to you pretty well? Vectors helped, didn't it? Because there's such a commonality between the two, huh? All right, moving on to C. C asked you to find the reciprocal of Z2. Some students forgot this one today. Do you remember, Jake?
Yeah, I think so.
So what do you do with the modulus?
Divide.
What do you divide?
Modulus. I don't know.
Well, you have one of them, 4.5. What do you divide?
I would put the 1 over the 4.5.
Okay, yes. You take the reciprocal of the modulus, and you take the
I don't know what to do with the degrees.
opposite of the argument. Now, what is 1 over 4.5, Jake?
0.222.
Say?
0.2
Okay,
repeated.
so 0.22 cis. Now, once again, can't have a negative angle, so you
Add 360.
add 360, and you get
243.
243. Any questions so far? All right. D is taking Z2 and raising it to the 5th power. You take the modulus and you
Raised to the 6th power.
raise it to the power,
Or fifth.
5th power.
5th, sorry.
You take the argument and
Multiply it
multiply it
by the power.
by the power. What do you get for 4.5 to the 5th, Jake?
1845.3.
Say it.
1845.
Say it correctly.
1845.
thank you.
0.3.
0.3. And when you take 117 times 5,
585.
and
Subtract 360.
subtract 360. Is this right? 1,800?
Yeah.
Okay. 1,845.3 cis
225 degrees.
225. Lastly, you also can take the root of a complex number in polar form. And how many answers are there? 3. So if your Z1 is 6.7 cis 297, you take the cubed root of the
Modulus.
modulus, you take the argument, and
Wasn't that thing when you added 360 and
that's right. It's actually K, but N is fine. To get 3 answers, though, you divide by 3.
oh yeah.
So what is the cubed root of 6.7?
1.88. So 1.9.
So 1.9 cis. How do we know that 297 divides by 3?
You can add up the digits.
You add up the digits. What's the sum of the digits?
18.
18. What else does it divide by?
9.
9. That's right. What is 297 divided by 3? 99?
99.
So this is 99 plus 120K. So our first answer is 1.9 cis. 99. That's when K is 0. Our second answer is 1.9 cis.
120. Sorry.
Plus 99. So 99 plus
219.
120K, first you put in 0 for K, then you put in 1, and then you put in 2, so cis.
219.
And my last answer, 1.9 cis. Okay, that's it.
339.
Kylie, hand it in.
339.
I need it right now. I can't give you more time. It's just not fair. All right. We now move to the next unit that we studied. Which was matrices. If you need a note back to class, you write it and I'll sign it. And thank your teacher for me. With matrices, what did we spend most of the unit doing? Row operations.
No.
Remember how well you actually did, though? At first, everybody was moaning and groaning about it, right? But eventually, some of you actually thought it was kind of fun. Who thought it was fun?
Absolutely not.
There were 3 fair moves with row operations. 3 things you were allowed to do. Any recollection, Jake?
You could add an entire row to another row.
Okay. Add a multiple of 1 row to another row. What else could you do?
You could
Switch to.
You could
interchange.
switch or interchange 2 rows. What else could you do?
My row heading.
Multiply an entire row
I know.
by a non-zero number. We also used row operations to accomplish 2 things. Jake, what did we use row operations to do?
Find inverse.
Find an inverse. And what?
Identity matrix.
We used the identity matrix. What else did we do?
Oh, the augmented one?
We solved a system. When we were doing finding an inverse, what was the start and what was the end? Let's say you had one that was 1, 2, 3, 4, 5, 6, 7, 8, 9. What did you do with that 3 by 3 matrix to find its inverse?
You had to get it to the identity matrix.
Okay, so what did you do? You did something that starts with A.
Augment.
You augmented the matrix with the identity matrix. The identity matrix is a matrix with 1s at its main diagonal and 0s everywhere else. And your goal was
Let's get the identity on the left side.
to get the identity matrix on the left side and what did that turn the right side into?
The solution matrix.
The inverse. So you took your 3 by 3 matrix, augmented it with the identity matrix, you performed row operations with the goal of turning the left side into the identity matrix, and whatever you ended up with on the right side, that was now the inverse of the matrix you started with. What if you had a system such as x plus y plus z equals 21, 2x plus y equals 23, and y plus 3z equals 25. How did row operations work on this, Jake?
You'd first plug it into a matrix augmented with this solution.
That's right. You took your coefficient matrix, 1, 1, 1, 2, 1, 0, 0, 1, 3. You augmented it
With the solutions.
with the constant matrix,
Constants.
That's how it starts. You performed row operations on it, turning
The left side into the identity.
the left side into the identity matrix. And whatever you ended up with on the right side became the
Solutions.
solution to your system. Yes?
Sorry, I was like asking this part and I never understood it. So how did you, what steps do you get in between,
Here and here?
Yeah.
We're gonna do the
oh,
problem.
sorry.
But before we do the problem, there were two unusual cases when solving. So, most of the time when you solved, you got an answer like the one we're going to do here in a minute. But there were a couple of unusual cases. Do you remember, Jake?
Yeah, it's when there's like 3 zeros in a row.
What were you going to say, Diego?
Or it equals 0.
Okay, but what's the
4 zeros in a row, sorry.
Okay, but the question is, what does that give you? So when the answer is no solution, what happens is,
4 zeros. Is that-
no, actually, with no solution, you get 3 zeros in a row.
Equaling a number.
Excuse me?
And a number on the other side.
Yeah, but it does not matter which row it is, but one of your rows turns into 3 zeros. You don't get 0 on the other side. And this is no solution because because I solved it all the way, I do know that x is 4. And I do know that z is 8. The third line says that 0x plus 0y plus 0z is going to equal 2. And that never can happen. And that's why the answer is no solution. And when it was no solution, we said the system was inconsistent. The other unusual case when you were solving was when the answer was
All solutions.
all real numbers, also known as infinitely many solutions. What did that look like?
4 zeros in a row.
That's when you got 4 zeros in a row. It does not matter what row it was. If one of the rows has 4 zeros in a row, that just then created all real numbers. Because while you're clear that x is indeed -5, and y is indeed -2, 0x plus 0y plus 0z is 0.
Always.
And that can happen infinitely many times. Because no matter what z is, if you multiply it by 0, you will get 0. And so this system is consistent. And is it dependent or independent? Dependent. All real numbers means basically that all three lines are the same line. Which means the lines are completely dependent on each other. The regular one became consistent and independent. Now, there were some other things that we learned in this unit. We learned Kramer's rule, but this is what we spent the most time on. So it's probably the most important topic, right? Would you like to solve this one and remember how to do it?
Yeah.
Okay. So, remember, I taught you to underline what you were going to change. And if you wanted to change that 2 into 0, what did you do? Jake?
You could multiply row 1 by -2 and then add it.
-2 times row 1, added to row 2, put in row 2. So 1, 1, 1, and 0, 1, 3. 2 times 1, -2 times 1 is -2 plus 2 is 0. -2 times 1 is -2 plus 1 is -1. -2 times 1 is -2 plus 0 is -2. -2 times 21 is -42 plus 23, is that -19? Now, unfortunately, you just changed a 0, or lost a 0, but you kind of have to trust the process, right?
And we lost the 1.
And let's say now you want to change that 1 right there to a 0. What would you do, Jake?
I would add row 2 to row 1.
Row 2 plus row 1,
In for row 1.
put in row 1. So 0, -1, -2, -19, 0, 1, 3, 25. Simone, you getting what you asked for? 0 plus 1 is 1. -1 plus 1 is 0. -2 plus 1 is -1. -19 plus 21 is 2. Now I'm going to skip the -1 and go to that one because I know that I can always multiply through by a negative later. But suppose that's what we want to change. Can you see why it benefits us to keep it as a negative right now? So what do we do, Jake, to turn that into a 0?
Row 2 plus row 3 in for row 3.
Row 2 plus row 3, put in row 3, 1, 0, -1, 2, 0, -1, -2, -19. 0 plus 0 is 0. -1 plus 1 is 0. -2 plus 3 is 1. -19 plus 25 is 6. Oh, I forgot to mention that you're always welcome at the beginning of the problem to solve it on your calculator. Did any of you do that? You did, Jonathan? Oh. If you solved it on the calculator, I believe you get 876. And then you get to confirm, oh, good, Z is 6. That's what I thought. At this moment, that last row is the most user-friendly row. By using this one, you can change the items in the third column without getting rid of things you already have. Once again, I'm leaving this negative to the end. I don't have to, that's my choice. And now let's say that I wanted to change that -1 right there into a 0. What would I do, Jake?
Add row 1 to row 3.
So row 3 plus row 1, put in row 1. So 0 plus 1 is 1, 0 plus 0 is 0, 1 plus -1 is 0, and 6 plus 2 is 8. Had you checked it, you would have said, oh, good, I got 8. Now, you would want to change that -2 right there into Jake a 0, and you would use row 3, and what would you do?
2 times row 3 plus row 2 in for row 2.
Good. 1 0 0 8 0 0 1 6. Have you been doing this with us? Two times 0 plus 0 is 0. 2 times 0 plus -1 is -1. 2 times 1 is 2. Plus -2 is 0. 2 times 6 is 12. Plus -19 is -7. And now I just have one last thing to do.
Row 2 by -1.
Multiply row 2 by -1, so -1 times row 2, put in row 2. And I'm just too lazy to write that again. So, there you go. How many of you are glad we reviewed row operations? All right, with the remainder of the time, I can either begin talking to you about the Chapter 7 unit with the power, logarithmic, logistic, exponential, all that, or I can talk to you about the Chapter 15 functions with the limits and the discontinuities. Whatever we don't do today, we will start with on Friday, and whatever we don't finish about one of them today, we will finish on Friday. What is your preference? So Chapter 7 was about lots of different kinds of functions. One of them was linear, but chances are that's not one of them. Jake is doing a pretty good job, right? How many of you are glad it's not your turn to be up and be taped being up? I think he's doing a good job. He had to ease into it a little bit, but you got it going now. Henry, you will be taped on Friday. That's probably a really old-fashioned word, isn't it? Taped. Do you guys remember cassettes?
We had to use them for our AP Spanish final this year. It was terrible.
Any of you ever seen an 8-track?
Oh, yeah.
What?
Before cassette tapes,
No.
there was an 8-track, and it looked like the size of the box that like a DVD comes in. It's about that big, and you put it in.
Oh.
I'm aging myself. Monday's my birthday, but next year is the big one. What do I turn next year?
20. We said 20. We said 20.
What do I turn next year?
21.
50. All right. So besides
Did you say
linear, what other functions did we study?
Logarithmic.
Logarithmic, okay. What else do we study? Logistic. I heard exponential.
Power.
Power. I heard quadratic. And there's another one,
Linear.
starts with P,
Piecewise.
piecewise. When we studied the logarithmic function, or let's talk about their patterns. Who remembers one of the patterns?
There's a pattern.
Okay, logistic had no pattern, but it did have a cap. And it also had two horizontal asymptotes and a point of inflection. Its equation was the most complicated one, and that's why we saved it for the test, right? It was y equals c over
1 plus a e to the negative.
Nice job.
c over 1 plus ab to the negative x. Okay, who else remembers a pattern? Yes?
Power was multiply.
Good. Power was multiply, multiply. What was its equation?
Y equals
Y equals a x to the b. Not to be confused with exponential, which is y equals a b to the x. Did you remember that? Because x is in the exponent. That's a good one to remember, huh? And what's the pattern for exponential?
add multiply.
Add, multiply. Who's the inverse of an exponential function?
Logarithmic.
Logarithmic function. So what's its pattern?
Multiply.
Multiply, add. And what was the equation? Y equals a
Plus
plus
b log of x.
b log x. The quadratic one was the
Constant second.
constant second difference. Its equation was y equals
Ax squared.
ax squared plus bx plus c. And the piecewise one didn't really have a pattern or anything. It just was delivered to you in pieces of functions. If you think back to your tests that you've had, we already said that we saw things like this on the free response for vectors, right? And we definitely saw things like this on the free response for polar, right? And did you have row operations on the free response for matrices? And when you got to chapter 7, what was on the free response? Word problems. So because I know we don't have time to actually complete it one now, we will end for today. I would like you to return your rulers to the box for me. Next class, we will start with some word problems from chapter 7. And then go to chapter 15. And then we will take out multiple choice. We also have a day next Friday, a half day. To review more multiple choice.
None.